Three-dimensional figures, or solids, are all around us and used and seen in our everyday lives. Solids are three-dimensional figures because they have a length, depth, and height. Instead of just knowing about how to spot different three-dimensional figures in our everyday lives, it would be neat to know how to find specific information about these objects, such as their volume or even surface area. Volume is the number of cubic units needed to fill the space occupied by a solid figure. The surface area is the sum of the areas of all of the surfaces or faces of the three-dimensional figure. One day after a math lesson on three-dimensional figures, a 7th grade student named Jill went on a mission to find as many objects that were in the shape of cones, rectangular prisms, and cylinders. On her way home from school, Jill passed a construction zone. The zone was blocked off with bright orange construction cones. Not only did they catch her eye because of their bright orange color, but also because they were cones. She couldn't believe that she had already spotted a cone. Then she thought to herself the definition of a cone, which is a surface that is generated by a straight line, passing through a vertex and moving along a fixed curve. Now that she had successfully discovered a cone, she took the measurements of it to calculate the volume. She wrote down the measurements of the cone and found the radius to equal 7 inches and the height to equal 18 inches. She also remembered that pi is about 3.14. When she performed the calculations and plugged the numbers into her formula, which is 1/3 pi r squared times height, she found the total volume to be 923.16 cubic inches. Once she left the construction site, she happened to walk by an ice cream cone and snow cone stand. Rather than taking their measurements, Jill decided to make a prediction about the snow cone, ice cream cone, and orange construction cones that she had spotted. She guessed or predicted that the orange construction cones would have a larger volume than the snow cones and ice cream cones would. Do you think that she made a good prediction? Next door to the ice cream and snow cone shop was a paint store. Here she spotted many different sized paint cans. She was so excited that she had located some cylinders. Cylinders are solid figures that have two congruent, parallel circles as their bases. There were so many paint cans to choose from, but she decided to take the surface area of a medium-sized paint can. The formula for the surface area of a cylinder is 2 pi r squared plus 2 pi r h. She measured the radius and found it to equal 3 inches. Then she measured the height and found it to equal 6 inches. Once she put all of these numbers into her formula, she found the total surface area to be 169.56 square inches. She eventually went on her way home, but remembered that her mom asked her to pick up a can of cream of mushroom soup for dinner. She was so excited because she was going to get another chance to find and analyze another cylindrical object. She arrived at the grocery store and predicted that the surface area of the soup can was smaller than that of a medium-sized paint can. Do you think that she was correct with her prediction? On her way to checkout, she came across a box of cereal. This was her chance to jot down her findings of an example of a rectangular prism. A rectangular prism is a solid figure that has two parallel and congruent sides or bases that are rectangles. She measured the cereal box and found that the length equaled 7.5 inches, the width equals 2.5 inches, and the height equaled 12 inches. Once Jill put these numbers into the formula of the volume of a rectangular prism, which is volume equals length times width times height, she found the total volume to be 225 cubic inches. Finally, once she reached checkout, she was glancing at a pack of gum. Rather than taking the exact measurements of the pack of gum, she predicted that its volume would be less than the volume of the box of cereal. Do you think that Jill made a good prediction? As you can see, three-dimensional figures are all around us. Next time you are out at the grocery store, taking a walk, or even sitting around your home, try to spot some three-dimensional figures.